Hello students, last class we have discussed about the ring system of wiring. Today's class also I am going to continue from the same ring system of wiring. See, the diagram shows the ring system of wiring. This is the commonly used system of wiring in our houses. In this system we have a separate ring for each portion of a house. Okay, the house we may have different rooms, right? Different portions. So the ring system, there is a separate ring system for each portion of a house. In a portion, the wire starting from the distribution board runs around all the rooms of that portion and then it comes back to the distribution board. Thus it forms a ring. So we call this system of wiring as the ring system of wiring. In this system, the live wire from the distribution box has the fuse connected in it before it forms the ring system. This fuse is called as the main fuse, which has the current rating of about 30 ampere. This fuse is called as the main fuse, which is connected in the live wire, which has the current rating of 30 ampere. Now in this ring system, this given circuit, I have connected the bulb and a fan. Okay, and how it goes to the other appliances. Suppose if the appliance has a 3-pin plug, how it is connected. First you see that in the case of a bulb, one terminal of the bulb is connected to the live wire through the fuse and a switch. See, from the live wire the lead is taken, it is connected to the fuse, then it is connected to the switch, then it connects to the one terminal of the appliance, the bulb. The other terminal of the bulb is directly connected to the neutral wire. Next you see the fan. One terminal of the fan is connected to the neutral wire directly. The other terminal of the fan is connected to the live wire through the regulator, switch and a fuse. Okay. So generally in any appliance, one terminal of the appliance is connected to the live wire through the separate fuse and a separate switch. The other terminal of the appliance is connected directly to the neutral wire. Suppose if you want to connect the 3-pin plug, the appliance has 3 points. Then one terminal of the appliance is connected to the live wire through a separate switch and a separate fuse. Other terminal of the appliance is connected to the neutral wire directly. The metal covering or the earth terminal of the appliance is connected to the earth wire. Okay, this is the way the appliances are connected in the ring system. That is, each appliance is connected separately to the ring system of wiring. If you want to connect one more appliance, you can connect the lead from the live, one lead from the live wire, one lead from the neutral wire, and before the live wire is connected to the appliance, connect the separate fuse and the switch in the system. Yes. And why we go for this ring system of wiring? There are few advantages of this ring system of wiring. They are, first one is, every appliance is connected through 2 wires. That is, every appliance has 2 independent paths for the flow of current, 2 separate paths for the flow of current. That is, through one wire the current flows into the appliance, through the other wire the current returns back. So every appliance has 2 separate paths for the flow of current. Every appliance, you can check here, it has 2 separate paths for the flow of current. So the appliance is connected to the mains through the thick cables. That is, whatever is the current rating of the appliance, they will be connected with the wires of proper current carrying capacity. Whatever is the current rating of that appliance, they will be connected to the wires of proper current carrying capacity. And the appliances are connected to the mains through the proper current carrying capacity. This reduces the cost of wiring. Suppose the appliance requires a thick cable for its connection. Okay, But the ring system need not be made up of thick cables. It can be made up of thin cables, but only from the ring system, when the appliance is connected, we make use of the thick cables. So that appliance is connected to the mains through thick cables. This reduces the cost of wiring. The first one is the ring system of wiring. The cost of wiring can be reduced. Cost of wiring can be reduced in the ring system of wiring. The appliance can be connected to the mains through the thick cables. Second one, the plug and the socket used in the ring system can be of same size. That is, the same size plug and the socket can be used because each appliance has a separate fuse of proper current rating. So the plugs and the socket used in this system can be of same size. Plug and the socket used in this system can be of same size. Third one, if you want to connect any new appliance in the room, the connection need not be taken from the distribution board. Directly you can connect to the ring system of wiring which is running in that room. Okay. So the installation of any new appliance, the connection need not be taken from the distribution box. It can be directly connected to the ring system of wiring. Installation of new appliance. And the fourth one is, if the fuse of one appliance blows off or any fault in this appliance, this will not affect the working of the other appliance. That is, each appliance can be operated independently. Okay, the fuse of one appliance blows off, it will not affect the working of the other appliance. Each appliance can be operated independently. Each appliance can be operated independently. These are all the advantages of ring system of wiring. Okay. So the advantages of ring system of wiring, the cost of wiring can be reduced. Each appliance is connected to the distribution board by thick cables or to the mains through the thick cables. This reduces the cost of wiring. Second one, the plugs and the sockets used in the system can be of same size because each appliance has the fuse of proper current rating. Next one, any new appliance to be installed in the room, the connection need not be taken from the distribution board. It can directly be connected to the ring system which is running in that room. Next one, every appliance can be operated independently. The working of one appliance will not affect the working of any fault in one appliance will not affect the working of the other appliance. Okay. Next one, if you see in this diagram, all the appliances are connected parallel in the circuit. Yes. Why we go for the parallel connection? Here I have shown you the circuit diagram where take this one as bulb B1, this is bulb B2. The two bulbs are connected in series. Yes. This is the battery source where the two bulbs are connected in series in the circuit. Let me take this as key K1, this as key K2. Yes. This is the battery. Now, when the two bulbs are connected in series, the current flows from the battery. When the key K1 is on and K2 is also on, the current flow, both the bulbs are connected in the closed circuit, and when the key K1 and K2 are closed, both the bulbs will glow. They will get the current supply from the battery and both will glow. But if the switch K1 is switched off, okay, then the bulb B2 will also stop glowing. The reason is that the bulb B2, when the key K1 is closed, the bulb B2 will be connected in the open circuit. So no current flows into the bulb B2, so it will not glow. Or if anything goes wrong with the bulb B2, that is the fuse of the bulb B2 blows off, then the bulb B1 will also be connected in the open circuit. Okay, this blows off means here you will have a gap. Then the bulb B1 will be connected in the open circuit. The bulb B1 will also stop glowing. So both the bulbs in series connection, both the bulbs will glow simultaneously, or if one bulb does not glow, the other one will also stop glowing. Okay, that is each appliance cannot be operated independently. They work simultaneously. But come to the parallel connection. Here the two bulbs B1 and B2 are connected in parallel. Yes. Suppose the fuse of the bulb B1 blows off. Okay. The bulb B2 will continue to be connected in the closed circuit. Right. So in this condition, the bulb B2 will glow when the B1 is switched off or it fuses. Okay. So the parallel connection, both the bulb can be operated, or if the bulb B1 blows off, B2 will continue to glow. That is, each appliances can be operated independently in parallel connection. If one bulb fuses off, it will not affect the working of the other bulb. This is the main advantage of the parallel connection. Okay. Next one, in the parallel connection, when the appliances are connected in parallel, both will be connected to the given potential. Whatever is the terminal voltage of the battery, both the appliances will get the same potential difference for their operation. Yes, that is, both the appliances can be operated at the rated voltage. But in series connection, the voltage is getting divided among each appliance in proportion to the ratio of their resistances. Okay, so their voltage is getting divided. They will not get the required voltage for their operation. This is the second disadvantage of using the series connection, but which can overcome in the parallel connection. Each appliance will be operated at the rated voltage. Whatever voltage you are applying across the battery, both the bulbs will be getting the same voltage. But here the voltage get divided across each appliance in ratio of in proportion of their resistances. One more thing in series connection, if one more appliance is connected, the resistance included in the circuit will be increasing. That reduces the current in the circuit. Okay. Because of these advantages, we always go for parallel connection. So in the case of parallel connection, each appliances can be operated at the rated voltage. In parallel connection, the potential difference across the appliance will be equal to the potential difference applied by the source. Okay. Applied across the source. So each appliance will get the rated voltage for their operation. Second one, if the fuse of one of the appliance blows off or any fault in one appliance, that will not affect the working of the other appliance. Each appliance can be operated independently. Whatever is the disadvantage we have in the series connection, that can be overcome in the parallel connection. Because of this reason, all the appliances are connected in parallel in the ring system of wiring. In the house, all the appliances are connected in parallel so that each appliance can be operated independently and each appliance will be operated with their rated voltage. Okay. Next, we discuss about the fuse. Already we have discussed about two fuses. We have come across two types of fuses. Yes, one is company fuse or the pole fuse, which is connected in the pole, which has the current rating of 50 ampere. And one more fuse we have come across in the ring system of wiring, the household wiring system. The other one is main fuse, which has the current rating of 30 ampere. Company fuse or the pole fuse is fixed in the pole, which has the current rating of 50 ampere. Main fuse is connected in the distribution box before the wire connection is given to the ring system of wiring. Main fuse is connected between the ring system and the kilowatt hour meter in our houses. The main fuse has the current rating of 30 ampere. Already I told you the current rating means the fuse will allow the permissible amount of current to flow through it. Here 30 amperes means it allows, the main fuse will allow only 30 amperes of current to flow through it. If the current exceeds in the circuit due to overloading or due to short circuiting, the fuse gets heated up, it melts and it breaks the circuit. Okay. So I can call the fuse as the safety device. That is, when the current exceeds the permissible limit. The reason for exceeding the limit is maybe due to overloading. What is the meaning of overloading? The total power drawn from the circuit exceeds the power for which the connection is taken. Okay, if the connection is taken for particular limit of power, but you are connecting many appliances, the total power consumed the appliance is more than the power for which the connection is taken, then we call the circuit is overloaded. This overloading of the circuit may lead to voltage fluctuation. Okay, due to overloading, excess current may flow in the circuit. The second one is due to short circuiting. Short circuit means when the live wire comes in direct contact with the neutral wire. This happens because of the removal of the insulation in the wiring. Normally the live wire, neutral wire and the earth wire all are covered with the insulation medium. That insulations will be provided with different colors. For live wire, the insulation is normally provided with a red color or with a brown color, and for the neutral wire, normally the insulation is provided with a black or light blue color. Black or light blue color. And for the earth wiring, normally the insulation is made with yellow or green. The ring system we have made use of for live wire, we have represented with the red color, neutral wire with blue and earth wire with green. Okay, these are the color code of insulation used for the different wires. Okay, and so the fuse safeguards the circuits against the overloading or short circuiting. So when the current exceeds the permissible limit of current, that is, the fuse wire permits the flow of current through it only up to certain fixed limit, which is called as the current rating of the fuse. That is, current rating of the fuse means the fuse wire will allow only current up to only a certain fixed limit, which is called as the current rating of the fuse. When the current flows in the circuit, it passes through the fuse. The fuse gets heated up. It rises the temperature of the fuse to its melting point. That time the fuse melts and safeguard the circuit and the appliance from being damaged. That is, before the current reaches the appliance or the circuit, the fuse gets melts and it disconnects the main supply to the main current supply to the appliance. Thereby it safeguards the circuit and the appliance from being damaged. So we call the fuse as the safety device. Fuse is otherwise called as the safety device because it safeguards the circuit and the appliance from being damaged due to overloading or short circuit. That means when the current exceeds the permissible limit, the fuse gets heated up, it melts, it breaks the circuit before the current reaches the appliance or the circuit. Thus it acts as the safety device. Next one, we discuss about the principle on which the fuse works. Okay, principle means here we have seen that when the current exceeds the permissible limit, the fuse gets heated up, it reaches the melting point and it melts and breaks the circuit. So it works on the principle of heating effect of electric current. The heat energy is generated by the electric current. The fuse works on the principle of heating effect of electric current. Okay. The rise in temperature of the fuse wire depends on two factors. One is the current rating of the fuse. The other one is radius of the fuse wire. The rise in temperature delta T is directly proportional to square of the current rating of the fuse and inversely proportional to cube of the radius of the wire. Yes, when the current flows through the fuse, the temperature of the fuse rises. This increase in temperature is represented by delta T. The increase in temperature of the fuse wire depends on two factors. They are the current rating of the fuse and the radius of the fuse wire. The rise in temperature of the fuse is directly proportional to square of the current rating of the fuse and inversely proportional to the radius of the fuse wire. The current rating of the fuse wire depends on the that is the thickness of the fuse wire depends on the current rating of the fuse. Yes, the thickness of the fuse wire depends on the current rating of the fuse. The higher the current rating, thicker will be the wire. The thickness is decided by the current rating of the fuse. The higher the current rating, thicker will be the fuse wire. Next one, the material used as a fuse wire. Okay. Normally the material used for making the fuse wire is alloy of tin and lead. Alloy of tin and lead. Why only these materials are used as the fuse wire means because these materials have two characteristics. One thing, they have low melting point. They have low melting point. Second one, their resistivity is high. They have high resistivity. So any material which can be used as the fuse wire should have the following characteristics. One thing, they should have low melting point and they should have high resistivity. Alloy of tin and lead, they have low melting point and high resistivity. So they are suitable for making the fuse wire. Okay. But aluminium and copper cannot be used as the fuse wire. They are unsuitable to be used as the fuse wire because the resistivity of aluminium or copper is very low and their melting point is very high of the order of 1080 degree Celsius. Because of these two things, they are unsuitable to be used as the fuse wire. Okay. There are different types of fuses. Cartridge type of fuses, porcelain type of fuses. So after the school reopens, I will show all these fuses are available in our physics laboratory. After the school reopens, I will show those fuses and explain to you. Okay. Next one, in the ring system of wiring, we had seen that the fuses always be connected in the live wire. Can you see in the diagram? See here for the fan, one terminal of the fan is connected to the live wire and the fuse is connected in the live wire. And the fuse for the bulb is again here connected in the live wire. The fuse is always connected in the live wire. Why we are connecting the fuse in the live wire? The reason is that when the current exceeds the rating of the fuse, every fuse will have the proper current rating. If the current in the circuit exceeds the rating, the fuse gets melted. It breaks the circuit before the current reaches the appliance. Okay, so no current flows into the appliance. Here I show the circuit diagram where the fuse is connected in the, here you can see the diagram, fuse is connected in the live wire. From the mains, two connections are taken. The live wire is connected to the appliance through the fuse. The neutral wire from the main is directly connected to the other terminal of the appliance. Suppose if the fuse here, the current flows into the appliance through the live wire and the return path takes place through the neutral wire. The current flows into the appliance and it works. Suppose the current, some fault in the appliance, due to some fault in the appliance or due to overload, okay, the fuse in this one blows off, okay, then no current flows into the appliance, okay, the appliance will not work. Now you can take out the appliance, do the repairing work and again you can connect the fuse. Yes, the circuit will work. Yes, here the fuse is connected in the live wire. Due to overloading or any fault in the appliance, the fuse blows off, no current flows into the appliance. Then we can carry out the repairing work and replace the fuse. Okay. But if the fuse is connected in the neutral wire, see the second diagram, from the mains, the live wire is directly connected to the appliance and the neutral wire is connected to the appliance through the fuse. The second diagram, the fuse is connected in the neutral wire. Okay. Due to overloading, the fuse blows off. Then the current cannot flow into the appliance. Now the appliance is connected in the open circuit. So the current will not flow into the appliance. It will not work. Okay. But this time we cannot touch the appliance to carry out the work. If the person touches the appliance, he may get an electric shock because though the fuse blows off, the appliance is still in contact with the high potential through the live wire. That is, the appliance is in contact with the mains through the live wire. Yes, the person touches the appliance may get an electric shock. Okay, to prevent this, the fuse is always be connected in the live wire. When the fuse is connected in the live wire, when the fuse blows off, if the person touches the appliance, he will not be come in contact with the live wire. Okay. Because neutral wire is at a potential of 0 volt, he will not get an electric shock. The repairing work can be carried out. But when the fuse is connected in the neutral wire, when the fuse blows off, the person touches the appliance, comes in direct contact with the mains through the live wire, and there is a chance for him to get an electric shock. So, it is unsafe to connect the fuse in the neutral wire. The fuse should always be connected in the live wire. Okay. Next one, how to write the relation connecting the current rating. Already I explained. Current rating means the fuse wire will allow the fixed amount of, that is certain fixed amount of current to pass through it. That is called as the current rating of the fuse. The current rating of the fuse can be written as current rating of the fuse I is equal to total power of appliance, total power of appliance in the circuit, total power of appliance in the circuit divided by voltage of the supply. This is the relation connecting. This is the relation for current rating of the fuse. The current rating of the fuse I is equal to total power of appliance in the circuit divided by voltage of the supply. That's what the total power drawn from the circuit should not exceed the permissible limit for which the connection is taken. If it exceeds, then the fuse blows off. Okay. So next class we will discuss about the other household circuits we are using, like switches, earthing and 3-pin plug. All these things we will be discussing in the next class. Okay. Already I have attached this one in the PDF form. Learn before you attend the next class. Stay home, stay safe.